Hello, today we are going to learn 1.6 first order linear differential equation. So we are going to solve some differential equations like this kind of thing. So I can give you some brief idea. So the goal for this class, we want to solve some first order linear differential equation, for example, like this one. Okay. This is first order, right? Because it's only one derivative, and it's linear because there's no power to the derivative and the y, to y derivative and the y. So linear. This is just the coefficient, okay? And this is the right side is like our capital F. In 1.2, we give the definition for the linear differential equation. So we are going to solve this kind of differential equation. Firstly, let's take a look at the definition 1. A differential equation that can be written in this form is called first order linear differential equation. A differential equation that can be written in this form, and this form is this one, okay? Ax dy over dx plus bx y, which is rx. So here ax, bx, and rx, they are all functions of x actually. And in this case, this differential equation is called a first order linear differential equation. Okay, definition for the first order linear differential equation. Now, if we take a look at the function ax, so if ax is not zero, we can divide this equation by ax, and we can simplify actually. It's just divide the coefficient of dy dx, and right now it's like a bx over ax, right? Bx over ax. Y equals rx over ax. Okay, and usually we write in this form. So we write down dy dx plus px y equals qx. So we make this to be the px, we make this to be the qx. Okay, and we call this is the standard form of first order linear differential equation. This is the standard form. So when we solve the differential equation, usually we need to simplify our differential equation, change that into standard form. And let's see. The general solution to this one is given by this formula. Okay, let's see. And then I will give you the proof of this solution later. Okay, the general solution to this dy dx px y equals qx is given by this one. So yx equals to e to the negative integral px dx times integral qx and e to the px integral px dx and then dx plus c. This is the formula. So in this section, we are going to use this formula to solve first order linear differential equation. So from this solution, it looks complicated, but I'm going to show you how do we get this solution and how to memorize or how to understand this solution. If we look at this solution, we can see this term happen a lot, okay, appear twice, right? So integral px dx, okay, we have this term. So next I'm going to show you proof why we have this term. let's see. We can make this to be I is e to the integral px dx. Okay? And what is our differential equation? I'm going to write down this way. Y prime plus pxy equals qx. Right? And now we use I. We see this equation. We use I multiple by this equation, both sides of the equation, multiple the equation by this I. Okay, so let's see, what do we have? E to the integral px dx y prime plus, so each term multiple by this term, right? And here e to the integral px dx px and equals e to the integral px dx and qx. Is that correct? So we just use this I times every term in the equation. And then now we look at the left side of the equation. Okay, let's think about the product rule. Okay, product rule. So this is like, this look like, okay, we still have y here. Okay, so this look like I y prime plus I prime y equals e to the px dx qx, because I is e exponential function like here. So I prime equals what? Derivative of this one equals exponential function, derivative is itself, right? Px dx. And the chain rule, the exponent derivative, which is px. So actually, I prime is e to the px dx times px. So which is this term? This term is I prime. And this term is I. So that's why we have I y prime plus I prime y. And the left side actually is the product rule, f prime g plus fg prime. So here is the product rule. So we can combine them into just I times y derivative. And then we integrate both sides of the equation. So we get I times y, which is, take the integral each side, right? So px dx, and then qx integral, and the variable is x dx. That's why we take integral of this thing. And then we want to solve for y. So we just need to divide by I. It's 1 over I, right? And then what is 1 over I? 1 over I is 1 over e to the p dx and 1 over something. So it's like 1 over x turns into x to the negative 1 power. So 1 over e squared is e to the negative 2 power, right? So here is e to the negative p x dx integral e to the integral and the qx and dx. And in the solution, it added c. So it's just a integral. For indefinite integral, we add just a arbitrary constant. So that's why we have this formula. Okay, and don't worry too much. I'm going to show you in the example, and then we will also do the exercise. After that, we'll totally understand how to use this formula to solve some differential equations. Let's take a look at example 1. Solve the initial value problem. And this initial value problem means we have differential equation, we also have initial condition, right? So let's take a look at this is dy over dx plus xy x e to the x squared over 2. Sorry, here is equals 2. And what's the initial condition? y0 equals 1. So this is the initial value problem. Let's see. Firstly, we need to tell is this standard form or not standard form. If it's not standard form, we need to change it into standard. But here it looks like the coefficient is 1, right? So it's a standard. Okay, standard form. And first we need to know what is our P, what is our Q. So Px is x, and the Qx is x e to the x squared over 2. So the first step, we can calculate this one. We use this a lot, right? So why not we just, sometimes in the formula we use this plus or sometimes we use minus. So let's just calculate the integral px dx. So which is x dx, plug in px, which is x squared over 2. X squared over 2. You don't need to add the c here. So our formula equals what? Let's see. Our formula equals to e to the negative of that one. So I can write down the formula again. P and integral e to the positive, okay, and the qx and the dx plus c. Okay. So plug in negative x squared over 2. We already got this term from last step, right? X squared over 2. And here, integral e to the x squared over 2 positive. And the qx, what is qx? X e to the x squared over 2, and the dx, and the plus c. Right? And let's simplify. Simplify, we can combine those two terms, add the exponent together. So this equals to e to the negative x squared over 2. And here, x e to the, when we combine, we add the exponent, x squared over 2 plus x squared over 2 is this one, dx plus c. And for this one, integral by u sub, is that right? U sub. U substitution. What is u? U equals x squared du 2x dx. So actually this one, after we do u sub, it should be integral of 1/2 integral e to the u du, which is 1/2 e to the u, which is 1/2 e to the x squared. So this integral equals to e to the negative x squared over 2, and here is just 1/2 e to the x squared. That's the when we do u sub for this integral, and the plus c. Okay, so this is the answer. You don't have to simplify now. You don't have to, but if you want to simplify, we can get the answer like, you can leave the answer like this one. Okay. Let's see. We don't need to simplify. Okay. Let's plug in our initial condition to find the c value. We want to use initial condition to find the c value. So let's see, y0 equals what? Y0 equals e to the 0, 1/2 e to the 0 plus c, which is given by 1, right? 1. Okay, simplify. So those are all ones. So it's like 1/2 plus c is 1. So what is c? C is also 1/2. And now we plug into our function. So yx equals to 1/2 e to the x squared plus 1/2. Okay, and you can leave the answer like this. But in the book, when you do the homework, sometimes they may simplify the answer. So simplify the answer is this one, x squared over 2 plus 1/2 e to the negative x squared over 2. Okay, let's see the first example. And we can try the exercise problem. Here is the exercise problem. I'm going to give the solution, but I suggest you to do this problem by yourself, okay, before you look at my solution. So P, be careful, -1. This is standard form. So the solution should be, I'm going to use the formula directly. P dx, firstly I write down the formula, e to the p dx, qx dx plus c, and e to the negative integral of -1 dx, e to the integral of -1 dx, e to the 2x dx plus c. And this is just e to the integral 1 is e to the x, positive, right? And e to the negative x, and e to the 2x dx plus c. And this is a pretty easy one, so e to the x dx plus c. And after we simply integral this one, e to the x integral is also e to the x. It's just e to the x plus c. So the final answer should be just this one, O e to the 2x plus c e to the x. Either way. Okay, that's the solution. Now let's try another example. Okay, example. Actually, we can do that as exercise problem. But let's do that as another exercise. Let's take a look. X dy dx plus 2y cosine x. Here x greater than 0. Firstly, when we take a look at this differential equation, be careful, this is standard form or not, because we need to find our P and Q, right? So if P and Q are wrong, definitely we cannot find the right answer. So let's see. We need to change this into standard form. That means y prime, I like to write down my prime form, but you can also write down dy dx. 2 y over x plus cos equals cosine x over x. Right. So let's see, what is P? 2 over x, the coefficient of y, and the Q, this one. What's the solution? Negative p dx q dx plus c e to the integral of 2 over x dx e to the integral 2 over x dx. Actually, if you want, you can calculate this. Like in the first example, you can calculate px dx before you plug into the formula. So it's integral 2 over x dx. You can do this, okay? And qx, which is cosine x over x dx plus c. So right now I just plug in p and q into the formula, and I'm going to solve those integrals. E to the negative 2 natural log, this one. And because x is greater than 0, we don't have to put f's value. Is that right? It's just x. Okay, greater than 0. And here, e to the 2 natural log x times cosine x over x dx plus c. Here I want to show you how to simplify this term. Okay, how to simplify this term and that term. We can do this as example, actually. Example 2. Okay, because we need a little bit simplify here. Let's see. Do you still remember what is the natural log property? For example, log x to natural log x, we can change this into natural log x squared. So this is called law of exponent law for the natural log, right? So when we simplify, for example, x cubed, we can also put the 3 to the front, 3 natural log x. So same thing here, we have e to the 2 natural log x, so we can put this 2 back into the exponent to x. So e to the natural log x squared. Why we want to do this? Because we want to cancel out e, exponential, and natural log. So this is just x squared. Okay, so we can simplify it into x squared. Let's see, we have another term which is e to the negative 2 natural log x. Same thing, e to the natural log x to the negative 2 power. Put this back. Use the power rule. So cancel those, x to the negative 2. So here we get e to the negative, okay, e to the, okay, so here we already simplified this one, is x to the negative 2, and here is x squared, and the cosine x over x dx plus c, right? So next, let's just simplify this term. X squared cancel with the x, so x cosine x dx. And this is a by part, integral by part, so we skip the by part. You should be okay to find this thing, right? So by part there, was in calculus 2. I suppose everyone knows how to do this. So integral of that one is x sine x plus cosine x plus c. Okay. That's the solution. If you forgot to integral by part, you can go to the same calculus 2 chapter 5, I think, and review integral by part. Here I can do another exercise problem. Let's do another exercise problem. Okay, let's try this. So here's the solution, and you can see this is similar to our example problem. Just want you to be careful how to simplify this term, okay, and how to simplify that term. We can cancel the exponential e and natural log, okay. But before that, sometimes we need a little bit simplify. So that's the solution for the first order linear differential equation, and we just need the practice for this kind of problem. It's not difficult, just to plug in the formula and be careful we plug in the right px qx function, and then just to do the integration. For the integration, sometimes we may need u sub, sometimes we may need by part, integral by part, but they are just all the stuff. Okay, we can stop here for this section.